Okay, so we're going to look at lesson 7.5. We're going to start with example 10. I know I asked you to look at this last lesson, but I didn't think we really got enough time on it. It's similar to what you've done in the CASs in the last couple of weeks, but the major difference is that there's going to be some element of SUVAT. So there's some element of motion, where it's talking about distance, or it's talking about velocity, it's talking about time of the particles when they're actually moving. So the first part, finding the acceleration, is exactly the same as what we've been doing. So we start by drawing a diagram. It tells you that it's held at rest on a rough plane which is inclined to an angle of alpha, where tan alpha is 0.75. It tells us that friction is 0.5 and the particle is released and it slides down. Okay, so for a diagram, we've got an inclined slope. The angle here is alpha. We've got the object. Doesn't tell us the mass of the object, so I'm just going to call it M. So we've got mg, pulling it down vertically. You'll have the reaction force here, and then we've got friction. The box is sliding down, so we'll get friction going in the other direction. It also tells that tan alpha is 0.75. So at the side here, we're going to do ourselves a little triangle so we can get the values of sine and cos to go with it. It's 0.75, which is the same as 3 over 4. So the opposite we can label as 3, and the adjacent as 4, which is nice because then we can use the hypotenuse for Pythagoras, 3 squared plus 4 squared, and that will give us the 5. So then if we want to write down sine alpha, opposite over hypotenuse, opposite 3 over the hypotenuse 5, and cos alpha will be similarly 4 over 5. Okay, so now ready to find the acceleration. Oh, sorry, I should include mu. Mu equals 0.5. Right, then we're ready to find the acceleration going down the slope. So first thing I'm going to do is I'm going to find r. So I'm going to resolve in the direction of r. So that's going to balance. That gives us r equals, and it's going to be balanced out by this downward force. So firstly, we can see that this angle here is 90 minus alpha, and then that would give us that r is balanced by, we're going away from this angle because we're trying to go to the same direction as r. Okay, so we're resolving in the direction of r. So you can see that this is equal to mg, and then we're going away from the 90 minus theta angle, so it would be sine 90 minus alpha. And this is equal to mg of cos alpha. Remember that rule? We've got sine 90 minus alpha, it turns to a cos alpha and vice versa. So then we're going to resolve down the slope. This is the direction that we expect the object to move. So going down, we can see that the force is going to be mg cos 90 minus alpha, and all we'll have resisting it is our frictional force. So then our mg sine alpha, again using that rule, cos 90 minus alpha is sine alpha, minus the friction, which as always is mu r. So I substitute that in, mg sine alpha minus 0.5 mg cos alpha. That's using our value of r from the first part of my working out over here. So then all we're going to do with that is use it in F equals ma. Remember, we're looking for the acceleration. So I get that mg sine alpha minus 0.5 mg cos alpha is equal to m times a. So then we can see that I can divide the entire thing by m. I'll cancel all of my m's. And then I'm left with an expression for a, and all I need to do is substitute in. So I know that g is 9.8 I know that sine alpha from up here is 3/5. G again is 9.8 and cos alpha is 4/5. That will be equal to my A. I'm going to pop that all into my calculator very carefully. I get 1.96 meters per second squared. And that's the answer to part A. For part B of the question, it asks us to find the distance it slides in the first 2 seconds of motion. So, very similar to the SUVAT questions we've done previously on projectiles, but it's actually simpler. It's more Year 12 SUVAT. So, we're looking for the distance, which is s, and we're told that t is equal to 2. We've just found the acceleration using the forces, so that's going to come in at 1.96. And the final thing is either u or v. So what we know in the question is it tells us, if we just look back at the question, a particle is held at rest. So that means that we're starting with 0 velocity. So this is u equals 0. And then I've got enough information to find s, I can put it into one of the SUVAT equations. So you'd check your formula book and you'd find that it's related by this equation. And then we've got 0 times 2 plus 1/2 times 1.96 times 2 squared. So this is 3.92 meters in the first 2 seconds of motion.